Hi, I'm Paulo Mendes. I'm a master's student at PUC-Rio, Brazil, and I'm going to present the work entitled An Authoring Model for Interactive 360 Videos. The recent broad availability of consumer-level head-mounted displays has increased the popularity of 360 videos. Despite the limited look-around interaction supported by traditional 360 videos, interactive 360 videos support additional elements such as overlaid information and navigation. We propose an authoring model that allows authors to design and create interactive 360 videos. This model is part of an ongoing work towards the development of a fully immersive authoring tool for interactive 360-degree videos. We analyze different scenarios of immersive multimedia presentations based on 360 videos in order to gather the main requirements for our authoring model. The first scenario, 360 Hyper Video, is characterized by navigation among 360 videos. And besides that, it should be possible to add overlaid information to the 360 videos. An example of this scenario is a virtual tour in a museum where the viewer may navigate through different rooms. Each room could have additional information about the presented piece of art. The second scenario, Accessible 360 Video, aims at presenting together with a 360 video its translation in either sign language or subtitles. For the sign language case, a 2D regular video using picture-in-picture could be displayed. In the third scenario, 360 video with guided attention, the 360 video has a recommended region to look at. Whenever the user is not looking at the recommended region, there could be elements to guide his attention. Besides visual cues, spatial audio cues are also important in virtual environments and can help in guiding the user's attention. Based on the scenarios I have just described, we gathered these requirements regarding presentation. Overlaid information, additional media objects might be positioned in the 360 environment. Styling, different media elements may share the same position and presentation characteristics, so the author should be able to reuse the same style in different elements. 3D audio, that's basically the audio should be delivered differently to the user based on the head's motion. Subtitles, support subtitles both word referenced and fixed to the user. 3D spatial layout, the media elements should use a 360-based coordinate system. And presentation time, the media elements should be synchronized with the 360 video. We also gathered information regarding interaction. Navigation, which is to enable users to navigate between 360 videos. Hotspot, that defines a position in the 360-degree scene in which different actions may be performed when the user looks at it. Viewport preview, that is the use of a picture-in-picture live view of another portion of the video. Based on those requirements, we created an XML-based model. Presentation 360 is a root element of it. It has two children, head and body, similar to other multimedia languages. In the head, reusable objects can be defined so other media elements can reuse them. The body element is composed of different Scene360 elements, and its entry attribute indicates the ID of the initial Scene360 that starts with the application. The Scene360 tag is defined by its ID, source of a 360 video, and its volume. Each scene is composed of a set of media objects whose time behavior is related to the timing of the 360 video. In the current version, we support text, image, video, and subtitle media objects, which each one with its respective XML element. For positioning these elements in the 360 environment, we use a polar coordinate system in which the viewer is the center. The attribute phi specifies the horizontal angle, theta the vertical, and r the distance from the center. Also, the media object rotation makes it faces the center, which is the viewer position. For timing specification, we use SMIL begin and dur attributes that define the start and duration of the specified media object. Clip begin and clip end define the portion of the source media that's presented. Follow camera, it's a Boolean attribute that, if true, makes the element moves with the user's head motion. And onSelect, that refers to the ID of AutoCenter60, so that when the user selects the media object with this attribute, he is transported to the referred Center60, allowing navigation among different scenes. Besides traditional media objects, we also support some special elements. The first, Preview, that displays a preview of another 360 video using clip begin and clip end. It's mainly used for navigation together with the onSelect attribute. Hotspot, that is used to define an interactive region in space in a 360 video, and it has two special attributes. OnLookAt, that defines an element that begins once the user looks at the hotspot, and during not looking at, that defines a media object that starts when the user is not looking at the hotspot and stops when it's looked again. And Mirror, that defines a picture-in-picture live view of a viewport of the Center60. As a case study, we have implemented different applications based on the representative scenarios that we used to gather requirements. The first of these applications is the 360 Real Tour. That is an example of a 360 hyper video where the user can navigate among different scenes. In this application, the user is presented with different places of the city and can navigate to them by selecting their preview. Moreover, each of the Center60 has additional information attached to it. The second application, 360 as the Accessible Lecture, is an example of an application following the Accessible 360 video scenario. In this application, a 360 video lecture is extended with subtitles and sign language. In this application, and both of them have the attribute follow camera set to true, so that they follow the user's head motion. The third application, 360 Music Concert, is an application following the 360 video with guided attention scenario. In this application, the viewer is presented with a 360 video of a music concert, and while looking away from the stage, he is presented with a live view of the stage on the bottom part of his view. For defining the position of the stage, we use the hotspot element, and the mirror element is used to show the picture-in-picture live view of the stage, as it's showing this image on the left. Moreover, the audio of the concert is also positioned at the stage position, and it's also used to guide the user's attention. As the position of the audio and the hotspot are the same, we define it as a style in the head, and both elements reuse it. One of our current limitations is that we do not yet support 3D objects. Currently, our model can be easily used through text editors with an implementation integrated with the Unity engine. Our final goal, however, is to use the proposed model as a basis for our ongoing effort to create an immersive authoring tool for interactive 360 videos. Thus, the best way to interact with such a tool, how to interactively define the proposed media elements, hyperlinks, mirror, etc., how to expose the media in space, how to navigate among 360 video timelines during authoring time, is also an ongoing work. For further information, you can refer to our paper or contact me directly. And we also have a GitHub repository for this work. Thank you very much.